sway he roll it in your. That is a name, it's a terminology. And roll motions, rolling is the most important motion for ship safety itself, and also comfortability to passengers. And also cargoes can be damaged because of the roll. That's why it is coming first time. The reason is the wave forces in beam C. Beam C is a wave is coming from the side this way. Ship is moving in this way, and wave is coming in this way. That's why ship is rolling. And also wind forces, side wind, and also then cargo shifting, or sometimes passengers are moving. Okay. And also rudder is change the direction and gives you some rolling moment. Not good aspect is capsizing of ship if the roll motion is big, and also motion in this inertial forces. You may have an experience with rolling ship. Have you tried? Yourself have a experience on roll motion on the ship? Anybody? So do you have an experience of rolling motion of ship? Yes. Yourself? Yes. What else? You can have a similar situation. Car is not rolling much because it has a wide tires, but sometimes small degree of rolling when sometimes the turning motion of car. But bicycles, or sometimes plane. Plane. Airplane. Yeah. Yes, rolling. But it's not easy to experience such a rolling. Sometimes it is a hitting or some kind of trouble air. Then we may have some kind of rolling. And the worst one is a seasickness. So many people. I was in Ulleungdo, Dokdo in last July. Ulleungdo, Dokdo is an island far away from Korea, in between Japan and Korea, in the about middle. When we returning back from the Ulleungdo to the mainland, the weather was not good. So wave was rough. So several people has a seasickness at the ship. So how to minimize the rolling? The metacentric height, GM, helps to reduce. Or sometimes if it's not enough, then it can capsize. So stability, rolling motion are related with the metacentric height. Or there's a devices, roll stabilizer. We already see last time. So what is a wave cause rolling? Right? And stabilizer, they produce in reverse way of wave motion. How to desynchronize, anti-synchronize the wave motion by using some devices. So roll stabilization is several different ones. We already have a discussion last time. Bilge-Keel, stabilizer fin, anti-rolling tank. We also saw the small device I showed you in Eureka building, and roll stabilization also. So this one is a Bilge-Keel. Bilge-Keel looks like this one, long strip. So they increase the damping of ship motion. Spring mass vibration. Can you remember spring mass vibration? And damping helps to reduce down the vibration, right? Damping. So that is same terminology and also effect. Okay, and then fin stabilizer. It is more expensive and big. They extrude outside or retractable type or non-retractable. And they can be modified, their angle of attack. So 세월호 for Korean students, seawall ship has the kind of roll stabilizer, fin stabilizer. And then anti-rolling tank, we saw this the other time at Eureka building. So that they also anti-synchronize rolling motions by using valve and pump, air cushion. And rudder, if rudder is turned, then it gives you a rudder force. So that gives you a roll momentum. But that is not big, but anyway, this small one. So there is an advantage and disadvantage. Vertical, stabilizer pin, anti-rolling tank, rudder roll, stabilization, simple speed and space and something like that. We already have a discussion, so let's give up. The other idea is a gyroscope idea. So that can be YouTube, but I will not show you this one. And also there is another idea of salon, but it's similar, but it is very expensive. And also you need a big space and money. Dynamic stability roll. So roll motion has equation. You see springless. I don't know whether there is a springless. Oh, here it is. Here it is. So we remember the mechanical system of mass spring damper system. Right? Simple one. Mass spring damper. Right? And equation is something like this one. Right? So external force. And this is a damping term. This is a spring term, right? Spring term. And this is a acceleration inertia term, right? And you see, you already know that this is x and this is x dot. X dot means derivative by time, right? Time derivative. So you can see this is a speed, and this one is acceleration. Second derivative. So acceleration term, mass, so inertia, damping is related to the speed, and spring force is related to the position, right? Or displacement, you say. And then you already remember this is frequency, natural frequency, and damping ratio. Remember this. Same idea, same equation, but the more complex terms. There is only change. So coming back to the twice double second derivative, but this is angular acceleration, roll motion, angular acceleration, angular speed, and also displacement or angle. And so you can remember, imagine that this is a spring term, this is damping term, this is a acceleration or inertia term. And these parameters or the variables, looks simpler, but it is very complicated term itself, right? This I and K and another K, but this is derivative P, another KP, and this one is we already see that GM is a metacenter distance, right? Metacenter, and mass and center of gravity. So this one is the known items, but the other ones is complicated. Anyway, the basic equation type is same. External forces, sometimes there is a zero, sometimes there is. External forces can be something like a wind force, or sometimes it can be a wave force, or sometimes it can be a rudder force, rudder rotate. And pitch motion is rolling in y direction, y axis. So the long ship is pitching in this way. So when the wave is coming from the front, coming in this way, wave is coming from the side, the ship is rolling. Or wave is coming from the front, then it can be pitch motion. So there is a most forces, wave forces, ice breaking portion for icebreakers that can create. Right? If ship has a confront of high wave, rough sea, how the pilot, the captain will take the direction. Usually they take direction toward the wave. That's easier for you, rather than having a wave is coming from the side, but because rolling is more dangerous. So if there is a high wave is coming, usually captain goes toward the wave, right, the direction, or a little bit sideways, because my destination is somewhere there. I cannot go this way, then we can go a little bit side, but not beam sea. Beam sea is very dangerous. So pitching should be coming because we are confronting high waves. So taking seawater on the deck, water is coming over the deck. Oh, that's why there is a structural damage due to a slamming. Oh, propeller racing is propeller is above the water, so coming into the air. Propeller. So the rotational speed is changing when propeller is inside the water, out of the water, inside the water, out of the water. Then propeller speed and racing is coming in this way. That is not good. And motion induced inertial forces. So the people, passengers also have a problem, but also cargoes are having damages. So how to measure, reduce the speed, the course change, and load distribution inside the cargo load distribution, and also there can be a fins. Right. So you can see how the big wave is coming toward the ship, so that pitch motion is increasing. You see that this is very big wave. The camera is on the board, on the seat. On the sideway, another ship. Water is coming above the ship. Green water. And come to the captain room. It can be the damage. So you have a wiper is moving. Okay, enough. Okay, and then oh, we already see this one. And yaw motion. Yaw motion is rotation around the z-axis. Ship is moving in this way because of the wave forces. Also, the towing. When you tow the ship, because of several reasons, if you towing by using a rope, ship can tow. Then at times it is moving in this way. We call this as a yaw motion. So they cause deviation because of the angle of direction. And broaching is wording coming from the yacht. The sail is collapsing. This is dangerous for sailing ship. We call this as broaching. Because of the wind direction is changing differently. Right? Because of the yaw motion, wind is blowing in this way, but sail is moving in this way, then sail is collapsing, not providing you the forces. How to reduce trim by stern? Trim by stern is on purpose. You can make ship a little bit trim in this way. Stern is more down. Or rudder steering. So you can use a rudder because if you have a driver or car, if car is moving in this way, then you can control your handle to reduce the direction and change. Or there is an anti-yaw scale. You see, this ship has a 2 vertical plate. Toward the end of the ship, the propeller is here. So we call this is a scale. So 2 scale make ship can make it go direct rather than moving in this way. Right? There are several ideas. So your stability, this is a traditional. So we want to make a turning of a ship in this way. Original path, it is unstable ship can rotate in this. When you expect cycling or car, similar, and there is a different stability classifications. One is a line stability when there is a disturbance hitting by the wave or something. And once the direction is changed, then the car or ship is going directly in reverse way. We call this is stable, but it's a line stability. Or directional stability, when there's a disturbance, it goes to the original direction. The direction is stable. And positional stability, returning back to the original position. This is the best, right? Naturally, does not come. So you need to have some control mechanism to returning back to the original position. It is very similar to your automotive car driving, right? Or airplane, all the same. So the best way is returning back to autopilot, or unmanned car nowadays. They want to be like this one. There is some wind is blowing, so that the direction is changed in this way. They want to return back to the original position, or navigation something. They want to make the direction for it. Question? Course stability and maneuverability. Right. The stability usually are saying in this way. So stability means ability to returning back to the original equilibrium state. If you touch, or we call this is external disturbance, small disturbance. And when the disturbance, something like a wind or wave, is disappearing, then the ball is coming back to the original position. We call this a returning to an equilibrium original state. Then the system is stable. Maneuverability is a handle system. The car, your car is good handling or turning. Sometimes they are saying, I have a new car, new car is very good for handling or something like turning. We call this the maneuverability for ship. The capability of moving a vehicle to a desired state. I want to turn the sports car very fast, but turning in the motion. Right? When you have a racing by something like a cycling or ice skating, the turning is most dangerous or difficult to make a high-speed turning. Same to the cars, same to the horse racing, same to the airplane, same to the ship. So maneuverability is turning ability something. So there is this one is reverse way. Stability, they are keeping the original direction. Maneuverability is turning ability. So there is a reverse way. They are conflicting each other. So we need to have a trade-off. So good design should be both systems. Autopilot. So Nomoto is a personal name, probably coming from Japan. He developed an equation coming from the previous damping mass spring equation similar. But here is a delta. Delta is coming from rudder forces or rudder angles. And psi is comes yaw motion or yaw angular speed and angular acceleration. And simply any feedback control is trying to measure the state and then trying to modify the state, right? So that the car or airplane or ship can be coming back to the original position. That is the function of autopilot. But that can be studied by occasional motions of a second derivative. Once again, the equations look simpler, but the T and OK, that kind of parameter is very complicated ones because ship is complex and big. Dynamic positioning. Oh, this is looks like FPSO. They are trying to collecting oils or gases coming from the seabed. And seabed is very deep, something like a kilometer deep, several kilometers deep. The cable, or it is not cable, it's a piping system. They transport gases and oils are collecting from the seabed. And then collecting to and store into the oil and gas tank. In this case, the ship cannot move. If the wave is coming, current is coming, if ship is moving, then the pipelines are cutting. That's why that kind of ship, which is used for production of oil and gas, they need to stay still at the position or within some kind of a boundary, confined boundary. And then there is a way of making a dynamic positioning using several propellers or other items to move against the wave and current. All right. Questions? No. Then we move on to lecture by who? Yes, sir.